stone. The reason we get rid of the fairing, of course, is it's a lot of excess mass on the vehicle. So when you get rid of it, you can accelerate the rest of the second stage faster and get the satellite that's on top of the second stage all the way to that geostationary transfer orbit without using quite as much fuel.
So now, while the second stage is accelerating, let's talk a little bit about where it's going right now. So we're going to a geostationary orbit. Now, as you guys probably know, going to orbit is not so much about going straight up, it's just about going really, really fast sideways. And so right now we're going to a geosynchronous orbit. This is a lot higher than a low Earth orbit where the International Space Station is, so it takes a lot more fuel to get there. And in fact, the second stage has to make 3 separate orbital maneuvers, or burn maneuvers, in order to get up there. The first is this first burn you're seeing right now on your screen. Then there'll be about a 17-minute coast period, and then a second burn, which lasts about 45 seconds. So
the main difference between low Earth orbit and geostationary, of course, is that distance. The reason the geostationary in particular is where this satellite is going is because it's going to be staying in the same spot in the sky. That just makes communications with the satellites a little bit easier. In low Earth orbit, you end up making a rotation around the Earth in 90 minutes. The satellite, the International Space Station sees about 16 sunrises and sunsets because it's in that same orbital zone. Geostationary orbit is much further out and it's moving a little bit slower, but angularly it's moving at
about the same speed.
About the same speed as the Earth is rotating.
And so it's actually pretty high up there. It's 36,000 kilometers up in the sky. So you can see this, we have an animation here showing exactly what the second stage is doing. You can see that first stage going back for landing, and then the first burn, which is happening right now. Then a 17-minute coast period, fairing deploys. And then coming up after the coast period, there's a second burn, really short, only 45 seconds or so. Then the payload separation, and then the satellite itself takes a little while using its own thrusters to get to the final 36,000 geostationary orbit, 36,000 kilometers.
And here's an excellent demonstration. You can see that the satellite staying over that exact same point looks like America in that animation. Of course, this is going to end up over Southeast Asia, but will stay over Southeast Asia for the entirety of its life as long as it stays within that geostationary orbit.
So like we were saying, now when you're exactly in the same spot in the sky from the perspective of someone on the ground, it's fantastic for communications equipment. If you have a satellite dish, you want to point at the satellite in order to use it for communications, you just take your dish, point it directly in the sky, and it appears as a stationary star, and you can bounce all your communications right off of it.
The same thing is happening with the drone video. When it's got its sort of communications up to a satellite, if the drone is sort of moving too much, as it tends to when you've got
the vibration during launch tends to shake around the satellite on the drone ship quite a bit.
Yeah, and the vibration during the landing activities.
We just heard that the first burn of the second stage, the first burn of the first stage is complete. That means the first stage is back on its way to a hopefully successful landing soon.
Fingers crossed.
Fingers crossed.